Hello guys, what's up? This is Sir EJ and welcome again to another math tutorial. In today's topic, we will be discussing all about permutations. These are the following objectives we need to attain in today's topic. At the end of the lesson, the students should be able to Letter A. Illustrate the permutation of objects. Letter B. List the possible ways a certain task or activity can be done. And letter C. Appreciate permutations as vital part of one's life. Before we start with our main discussion, let's try to review your previous knowledge about counting principle. Let's have an example. Ernan invited his close friends Melvin, Gelson, and Lain to his 16th birthday, which will be held at Woodlane Emus. He prepared a special table with chairs placed in a row to be occupied by his three friends. Number 1. List all possible seating arrangements. Number 2. In how many ways can they be seated in a row? And number 3, show another way of finding the answer in item number 1. Let's answer number 1. So for number 1, we need to list all the possible outcomes of the seating arrangement that can be made for the 3-person. So let's have the first seating arrangement. So it can be the first seat will be occupied by Melvin, the second seat will be occupied by Lain, and the third seat will be occupied by Gelson. So this will be the first seating arrangement. And then the second seating arrangement, the first one is to be occupied by Melvin, followed by Gelson, and then followed by Lain. Then the third arrangement will be Gelson, Lain, and Melvin. And then the fourth possible arrangement will be Gelson, Melvin, and Lain. Then we have the fifth possible arrangement. We have Lain, Melvin, and Gelson. And the sixth possible arrangement, we have Lain, Gelson, and followed by Melvin. So all in all, we have 6 possible ways they can be seated in a row. So this method is called systematic listing because we have list the possible outcome in an organized and systematic manner. Another method in finding the number of possible seating arrangements can be made is by using a tree diagram. Tree diagram is a simple way of illustrating sequence of events. The first step to construct a tree diagram is to write first the 3 elements of the given set. So we have the first element will be Melvin, followed by Gelson, and then followed by Lain. And then after that, we will draw a line here, and then we can write either Gelson and Lain here. So let's write first Gelson, and then we will draw another line here, Melvin, Gelson, and then the remaining one is Lain. So we will write Lain here. And then after that, we will draw a line here. So we have Gelson here. Obviously, we will write Lain here. Followed by, we will draw again another line, followed by Gelson. We have Melvin, Lain, and then Gelson. And then let's go with this one. So we have Gelson. We will draw a line here. It can be either Lain or Melvin. So in this case, let's write first Melvin. So we have Gelson, Melvin, and then the remaining one will be Lain. And then we will draw again another line here. So we have already Melvin here. So we will write here Lain. And then draw another line followed by Melvin. And then we have Lain. And then it can be either Melvin or Gelson. Let's write Gelson. Then draw another line. Lain, Gelson, then we have Melvin. And then We have Gelson here, so this one will be Melvin. Lain, Melvin, then followed by Gelson. And then after we have construct a tree diagram, we will now write the possible results. So we have Melvin, Gelson, Lain. This is the first possible outcome. We have Melvin, Lain, Gelson. This is the second possible outcome. And then we have Gelson, Melvin, and Lain, the third possible outcome. Then Gelson, Lain, Melvin, the fourth possible outcome. And then we have Lain, Gelson, Melvin, the fifth possible outcome. And the last possible outcome is Lain, Melvin, Gelson. So again, there are 6 possible ways Ernan can arrange his friends in his birthday party. Another method you can use to find the number of possible seating arrangement is by using fundamental counting principle, wherein it states that if there are m ways to do one thing, n ways to do another, and o ways to do another, then there are m times n times o of doing those things. Let's try to solve it using the fundamental counting principle. So, by using fundamental counting principle, we can easily find the number of possible outcomes. The only downside to this is we cannot get the exact list of those seating arrangement. It can only tell us how many possible seating arrangement can be made. Let's try to find the number of possible seating arrangement. We have m times n times o because there are 3 persons we need to arrange. These 3 boxes indicates the 3 chairs that will be used by Ernan's visitor. So on the first chair, there are 3 possible arrangements. Gelson can sit on the first chair. Even Lain can sit on the first chair. And also Melvin. So we have 3 possible ways the event can occur. Times, on the second chair, let's say for example, the one who sit on the first chair is Gelson. So on the second chair, there are only 2 possible person that can sit on the second chair. It's either Lain or Melvin. So there are 2 possible ways the event can occur. Then, the third chair, if on the second chair, Lain sits on the second chair, then the third chair, only Melvin can sit on this chair. So we have 1 possible way the event can occur. So we will multiply these 3 numbers. 3 times 2 times 1 will be equal to 6 possible ways. So there are 6 possible ways the event can occur. It is important for you to know or remember those topics that we have reviewed earlier because we will be using it in today's topic. Our topic for today will be permutation. What is permutation? Permutation is an arrangement of all or part of a set of objects with proper regard to order. Let's say for example, possible choices you have in creating your GCache password. So that is an example of permutation. And then another example is arranging 5 different books in a shelf. And another one, possible number of plate number can LTO create. So these are examples of permutations because in this example, the order is important. We have the methods in determining permutations. The first method is the systematic listing. The second method is by using tree diagram. The third method, we can also use two-way table in some cases or some example. And the fourth method is by using fundamental counting principle. Let's have our first example. Suppose you secure your bike using a combination lock. Later, you realize that you forgot the 4-digit code and you only remember that the code contains the digits 2, 3, 4, and 7. List all the possible codes out of the given digits. Determine the number of permutations made. So the given here is the numbers 2, 3, 4, 7, and we will construct a 4-digit code. And the method we will use is by using systematic listing. We will list all the possible codes out of the given digits. In systematic listing, we need to create a certain pattern for us to be able to easily construct all the possible lists of codes. So my technique here is to start first with number 2, and I will be listing all the possible codes that will start in number 2. So the first possible code will be 2, 3, 4, 7. And then after that, 2, 3, and then babaliktarin ko lang yung number 7 and 4. And then after that, 2, 7, and then 3, 4 again. And then 2, 7, and then again, I will place it alternately. I will start with 4, followed by 3, and then 2, 4, 7, and then 3, and then 2, 4, 3, and 7. As you can notice, there are patterns that is created here. So it's up to you to discover all of the possible codes that starts with number 2 has already been listed out. So if that is the case, I will be starting now with the second number, which is number 3. I will be listing all the possible codes that starts with number 3. So that number is 3, 2, 4, 7, followed by 3, 2, 7, 4. Again, discover your own pattern. And then can be 3, 7, 2, 4, 3, 7, 4, 2, 3, 4, 7, 2, and then 3, 4, 2, 7. And then after that, if all the possible codes starting in number 3 has already been listed out, let's start with the third number, which is number 4. Let's start with number 4. 4, 3, 2, 7 can be 4, 3, 7, 2, or 4, 7, 3, 2, 4, 7, 2, 3, 4, 2, 7, 3, and 4, 2, 3, 7. And then let's start now with number 7. 7, 3, 2, 4, 7, 3, 4, 2, 7, 4, 3, 2, 7, 4, 2, 3, 7, 2, 4, 3, and then 7, 2, 3, 4. Again, there are patterns that you can discover for you to easily list the possible codes out of the given digits. So these are the possible codes out of the given digits. All we need to do is to count the number of possible codes that we have listed. So all in all, there are 24 possible codes that we can use to open the combination lock of our bike. Let's check our answer using the fundamental counting principle. So we have a given 4-digit combination lock, and then we have the numbers 2, 3, 4, and 7. So this 4 boxes indicates the 4-digit combination lock. So on the first box, we can select here the numbers 2, 3, 4, or 7. So there are possible ways we can select a number here, and that is the numbers 2, 3, 4, or 7. So we will write 4 here. Times on the second box, if the first number we have selected here is 2, then on the second box, there are only 3 possible numbers here. The numbers 3, 4, and 7. And then let's say for example, we have selected here number 3. And then on the third box, we have 2 numbers on the third box, which is number 4 and 7. Times on the fourth box, if we will select number 4 here, then on the fourth box, we can only select one number here, which is number 7. So that will be 4 times 3 times 2 times 1, which is equal to 24 possible ways. Therefore, there are 24 possible 4-digit combination lock we can construct or we can use to open the padlock of your bike. So our answer on our first method is correct. Let's have our next example. A couple is planning to have 4 kids. On any birth, the children could be a son or a daughter. Use S to represent a son and D to represent a daughter. So we will be using a tree diagram to illustrate the number of possible ways the couple can have 4 kids. Let's write first a son here. So we have S, and then draw a line here, and then followed by son, and then daughter. And then on their third child, it can be either son and then daughter. And then on this side, can be son or daughter. And then on their fourth child, it can be son or daughter. This one again, son and daughter. And then son and daughter, followed by son and daughter. Then let's construct here the daughter. If the couple will have daughter as their first child. And then if the second child will be son or daughter. If the third child will be son or daughter in this side. And in this side can be son or daughter. And then again, write son and daughter. And then son, daughter, another son and daughter, and then another son and daughter. So this is how we construct a tree diagram. And then after that, we will write the possible outcome. So on the first one, it can be four sons. The couple can have four sons. All of them are all boys. And then it can be son, 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 and then daughter. And then it can be son, son, daughter, and then son. And then on the fourth possible outcome, it can be son, son, daughter, and daughter. And then on the fifth one, it can be son, daughter, son, son. And then on the sixth possible outcome, it can be son, daughter, son, daughter. And then on the seventh possible outcome, it can be son, daughter, daughter, and then son. On the eighth possible outcome, son, daughter, daughter, daughter. And then on this side, on the ninth possible outcome, it can be daughter, son, son, son. On the 10th possible outcome, it can be daughter, son, son, and then daughter. And then on the 11th possible outcome, can be daughter, son, daughter, and then son. And then on the 12th possible outcome, it can be daughter, son, daughter, and then daughter. And then 13th possible outcome, it can be daughter, daughter, son, and then son. And then the next one, daughter, daughter, son, and then daughter. And then on the next one, daughter, 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 and then son. And then on the last possible outcome, it can be daughter, 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 daughter. All of their child are all female. So there are 16 possible ways they can give birth to 4 children. Let's check this using the fundamental counting principle. So our given, so we have 4 children, and then it can be either son or daughter. We have 4 boxes, and we will multiply those 4 boxes. Those 4 boxes indicates the 4 children. So on their first child, it can be either son or daughter. So there are 2 possible selection. Times on their second child, again, it can be son or daughter. And then on their third child, it can be son or daughter. So there are 2 possible ways. And then on their fourth child, it can also be a son or a daughter. So there are 2 possible ways. And then we will multiply these 4 numbers. 2 times 2 times 2 times 2 will be equal to 16 possible ways. Therefore, our answer is correct. Let's have our next example. In how many ways can you place 9 different books on a shelf if there is a space enough for only 5 books? So our given here is we have 9 different books, and then we can only place 5 books on a shelf. We will construct 5 boxes here. So this 5 boxes indicates the 5 books that we will place on a shelf. So on our first box, there are 9 different books we can place on this position. So there are 9 possible ways. And then times on the second box, if we have placed here 1 book, and then on the second box, there will be only 8 different books. So this will be 8. Followed by, if we have placed 2 books here, 1 here and 1 here, then there will be only 7 different books here. And then again, we will subtract it by 1. it will become 6. And then if we have placed another book here, then this one, we can only select 5 different books here. So this will be the solution. 9 times 8 times 7 times 6 times 5, which is equal to 15,120 possible ways. So therefore, there are 15,100 possible ways we can arrange 9 different books on a shelf if there is a space enough for only 5 books. Let's have our last example. In how many ways can Aling Rosa arrange 6 potted plants in a row? We will use fundamental counting principle. There are 6 potted plants, so these 6 boxes are the position that we will place those 6 potted plants. So on the first position, we have 6 possible ways we can select for the first position. After selecting one potted pot here, we only have 5 ways to select on the second position. And then after that, after we have select one potted plant here, on the third position, we have only 4 ways to select on this position. And then again, subtract it by 1 for the fourth position. For the fifth position, subtract again it by 1. And then for the last position, subtract it again by 1. So we have 6 times 5 times 4 times 3 times 2 times 1. 720 possible ways Aling Rosa can arrange 6 potted plants in a row.